Hello everyone, this is Amit Brambhat, your professor for CS 110 at Laurel Ridge Community College. Today we are going to discuss chapter 15, networks. Let me go ahead and share my screen with you. So welcome to chapter 15. Here we explore how computer networks allow devices to communicate and share resources. This chapter covers everything from basic networking concepts to internet structure, protocols, firewalls, IP addressing, DNS, and cloud computing. Understanding networks is essential because nearly every application today, from emails to streaming to gaming, depends on reliable communication between interconnected devices. Here you'll learn the core issues involved in computer networking, including different types of networks and their characteristics. We'll discuss how local area networks are organized using computer topologies like ring, star, and bus. You'll also understand why networking technologies work best when designed as open systems rather than proprietary ones. Finally, we'll compare various home internet and connection types so you understand their advantages and limitations. We also will try to understand packet switching, the technique that internet uses to move data efficiently. We learn about key network protocols and their roles in communication. We'll also cover firewalls and how they protect networks. You will understand the difference between host names and IP addresses, how the domain name system works, and finally, the benefits and structure of cloud computing. A computer network is simply a collection of devices connected to communicate and share resources. These connections may be wired using copper or fiber optic cables, or wireless using radio or infrared signals. Examples of network devices include computers, phones, routers, printers, and servers. Networks allow these devices to exchange data efficiently and support everyday services like browsing, streaming, and messaging. Any device on a network is called a node or host. One major performance factor is bandwidth, which measures how quickly data can move. Bandwidth matters because high bandwidth networks support faster downloads, smoother videos, and efficient communication. Low bandwidth causes delays, buffering, and slow file transfers. Networking introduced the client server model. In this arrangement, a server provides resources and services while client requests them. For example, when you load a website, your computer acts as a client requesting data from a web server. This model is backbone of most modern internet interactions. A protocol is a set of rules defining how data is formatted and processed. Without protocols, devices from different manufacturers couldn't communicate. A file server is a specialized computer that stores and manages files for network users, ensuring secure and efficient access. Web servers respond to requests for web pages and deliver content across networks. Another model is peer-to-peer P2P, which shares resources among many computers without a central server. P2P systems distribute responsibility, making them useful for file sharing and distributed applications. A local area network or LAN connects computers within a small area like building. Three common topologies determine how devices connect. A ring topology forms a closed loop. A star topology connects all devices to a central hub, and a bus topology uses a single shared communication line. Each has advantages and weaknesses in terms of reliability and performance. This slide illustrates the ring, star, and bus topologies visually. The diagrams make it clear how messages travel, and how failures can affect the network. For instance, a break in a ring disrupts the entire loop, while the hub in a star is a critical point of failure. A wide area network or WAN connects multiple LANs across large geographical distances, such as cities or countries. A metropolitan area network MAN is designed for communication within and around large cities. A gateway is a system that handles communications between LANs and other external networks, ensuring proper translation between technologies. Here we see how multiple LANs connect via communication links to form a WAN. This layered design allows organizations to scale from small building networks to global operations while preserving local autonomy. The internet is a massive WAN that spans the entire planet. No single organization owns it. Rather, it's a distributed network maintained by many providers, organizations, and governing bodies. Its openness and decentralization makes it robust and scalable. A wireless network communicates through a wireless access point using radio signals. Bluetooth is another wireless technology designed for short-range communication, such as connecting headphones, keyboards, and smart devices without cables. Latency measures the delay between sending and receiving data, which affects responsiveness. The Internet backbone consists of high-speed networks maintained by major telecom companies. Internet service providers (ISPs) connect homes and businesses to this backbone, giving users access to online services. Historically, phone modems converted digital data into audio signals so it could travel over telephone lines. Today, DSL uses standard phone lines to carry digital signals, while cable modems use TV cable lines. These newer technologies provide much faster speeds than dial-up ever could. Broadband refers to high-speed internet connections of at least 25 Mbps. DSL and cable are considered broadband. Download speeds are typically higher than upload speeds because most users retrieve more data than they send. This asymmetry is common in consumer internet plans. A packet is a small unit of data sent across a network. Routers direct packets towards their final destination. Packet switching divides messages into numbered packets that travel independently across the network, then reassemble into the original message. This method improves reliability and efficiency. This slide shows how a message is divided into three packets and sent via different routes before reassembly. Even if the route becomes congested, packets still reach their destination, making packet switching more robust than sending entire messages all at once. A proprietary system uses private technologies controlled by a specific vendor, which can limit compatibility, interoperability, the ability of for hardware and software from different vendors to communicate is essential for modern networks. Open systems rely on standardized models and protocols so devices can work together regardless of manufacturer. Here the slide introduces the OSI reference model, which breaks network communication into 7 layers. Each layer handles a specific function such as routing, transport, or physical transmission. This layer design helps standardize communication and ensures compatibility. Network protocols are layered in a stack where each protocol depends on lower layers for support. Higher level protocols rely on lower level services to handle tasks like routing, addressing, and ensuring reliable delivery. These layers interact seamlessly to deliver data across networks. TCP handles breaking messages into packets and reassembling them at their destination. IP routes packets across networks towards their final destination. Together, TCP/IP is backbone of internet communication, ensuring reliability and proper packet delivery. UDP is a faster but less reliable alternative to TCP. It sends packets without ensuring they arrive, making it ideal for streaming and gaming where speed matters more than perfect delivery. Ping checks whether a remote computer is reachable, while traceroute maps the path taken by packets across the internet. Traceroute in action. Here the slide shows example output from traceroute utility. Each line shows a step or hop along the route to the destination. Traceroute is a valuable tool for diagnosing network relays of failures along the path. This slide introduces several important high-level protocols. SMTP handles email transfer, FTP handles file transfers, Telnet allows remote login, and HTTP retrieves web documents. These protocols sit on top of TCP/IP and define specific communication tasks used every day. Here is a table with high-level protocols. A port is a numeric identifier associated with specific protocol or service. For example, web servers commonly use port 80 for HTTP. Ports help operating systems determine which program should receive incoming data. MIME types define the format of files transferred via email or websites. For example, image, JPEG, or text HTML help receiving systems understand how to open the file. MIME stands for Multipurpose Internet Mail Extension. A firewall protects a network by filtering incoming and outgoing traffic based on rules defined in an access control policy. Firewalls help block unauthorized access, prevent attacks, and enforce communication policies. Messages may be blocked if they violate security rules. This slide shows how a firewall stands between LAN and the outside world. All traffic must pass through it. Oops, let me go back to the firewalls. Yeah. So all the traffic must pass through the firewall, enabling the firewall to monitor, filter, and secure the network. Network addresses. A host name identifies a computer using words separated by dots, while an IP address uniquely identifies it using four numeric values. Though they correspond, the mapping isn't straightforward. DNS handles the translation. Host names are easier for humans. IPs are easier for machines. Network addresses. This slide highlights IPv4 limitations. Because IPv4 uses only 4 bytes, it can support about 4.3 billion addresses. Nowhere near enough to cover smartphones, IoT devices, and global internet growth. Smartphones significantly accelerated the depletion of available addresses. IPv4 ran out of free address blocks in 2011, leading to adoption of IPv6. IPv6 uses a much larger address space, 128 bits, represented in hexadecimal groups. Both protocols run in parallel today as the world slowly transitions to IPv6. Domain name system. A host number is host number identifies a specific machine within a network, while the domain name identifies the organization or group. The top level domain appears at the end like .edu, .com, or country codes, indicating type or location. The DNS is a distributed system that translates host names into IP addresses. Domain names servers store mappings. Domain squatting occurs when someone registers a domain name intending to sell it at a profit. DNS tables should be unsorted for fast hash-based lookup rather than slow linear searching. This slide lists examples of top-level domains, including original TLDs like .com, .net, and .org. TLDs help categorize websites and provide structure to the global naming system. Here the slide shows country code top-level domains such as .uk, .jp, or .ca. Countries use these two-letter codes to identify national domains. Many organizations outside the US register domain names using these TLDs. Here we see additional modern TLDs such as .biz, .info, and .museum. As the internet grew, the new TLDs were introduced to expand naming options and reduce conflicts over domain availability. The internet began as ARPANET, a US Department of Defense project. Authority over IP addresses and domain names was later subcontracted to ICANN in 1998. Since then, the US government has reduced its direct oversight to support global multi-stakeholder management. The slide discusses FCC proposals that would allow ISPs to offer premium access tiers, potentially slowing down other users. Net neutrality argues that ISPs should treat all data equally, ensuring fair and open access for everyone. In cloud computing, third-party providers supply resources like storage, servers, and software over the internet. Examples include Gmail and major cloud platforms like AWS, Azure, and Google Cloud. Cloud computing allows users to scale resources and reduce infrastructure costs. There are several cloud models. Public clouds are open to subscribers. Private clouds serve specific organizations. Community clouds support shared needs among multiple groups, and hybrid clouds combine features of others. Each model offers different levels of control, cost, and flexibility. Blockchain acts as a decentralized public ledger for recording transactions. Each group of transactions become a block, which is added sequentially to the chain. Because the ledger is distributed and self-verifying, it has no single point of failure and is difficult to corrupt. This makes blockchain technologies attractive for financial and data integrity applications. Ethical issues, social networking. The slide asks about the effects of social networking. Popular platforms include Facebook, Instagram, X or Twitter, LinkedIn, and TikTok. Users include individuals, organizations, and communities. Benefits include communication, collaboration, and outreach. Disadvantages include privacy concerns, misinformation, addiction, and cyberbullying. Whether benefits outweigh costs remains as an important ethical debate. Who am I? The individual shown received two major awards. This refers to Douglas Engelbart, known for inventing the computer mouse and pioneering human-computer interaction. His awards include the Turing Award, the National Medal of Technology. I'll suggest that you pause the slide here and try to answer these questions yourself. SETI searches for extraterrestrial intelligence using radio signals. A protocol is a set of communication rules. Bill Gates received a knighthood honorary distinction from Queen Elizabeth for contributions to technology and philanthropy. The colonel reported that deaths in South Korea 2005 and Taiwan 2012 were linked to excessive computer gaming, highlighting concerns around digital addiction. Well, I hope you enjoyed today's class, and I hope to see you in the next one. Take care now. Bye.